Hello guys, welcome once more to class online. Now if you ever have a problem with electricity costing or electric field strength, topics on electricity, this video is going to super help you. Now don't forget that my name is Tutudami, and if you like this video or if you learn something from this video, click on the like button. We have a lot of content to share with you that will better help you deal with Jamb Physics. Now let's get to the question number 36. Calculate the force acting on an electron of charge 1.5 times 10 to the power -19 coulomb placed in an electric field of intensity 10 to the power 5 volts per meter. Now what is the force? Now that force is electric force. Now acting, if you have this coulomb, calculate the force acting on an electron. Now, and you were also giving force field, right? You were giving force field, and that is 10 to the power 5 volts per meter. Now what will now be the force? Do you have any idea? Anything electric field, go by this formula: E equals F over Q. That is the formula for electric field. But the question is not asking for electric field. The question gave you the electric field. The question say find the force. So therefore I will make E F or force the subject. That will become F equals E times Q, where E is the electric field and Q is the charge, which is then I'll plug in the parameters. What is my electric field? 10 to the power 5. Then what's the charge? 1.5 times 10 to the power -19 is the charge. That is the charge. Now then what else will we do? The 10 raised to the power 5, the powers of 10 will come side by side. 10 to the power 5 will come to 10 raised to the power -19, and that will become 1.5 times 10 to the power 5 minus 19, and that will become 1.5 times 10 to the power -14 Newton. And that is the force, making option D the correct answer. All you have to do is to know the formula for electric field strength, and this is the formula: E equals F over Q. Now you might want to go over the topic electric field all over again, but generally anything electric field intensity or electric field strength is E equals F over Q, and that is the answer to the question. Okay, let's get to number 37 now. Capacitors are used in the induction coil to what? Now we know generally that capacitors are things that store charge, right? But they have a slightly different function in the induction coil. Do you have any idea? Do they control circuit or dissipate energy or prevent electric shock and spark or prevent distortion of electric field? What is this capacitor used for on this induction coil? This is a capacitor. What is it used for on the induction coil? Now the answer is very simple. A capacitor is used in the primary circuit of an induction coil. This is because when the circuit is broken, a high induced voltage is used to charge the capacitor to avoid spark. Now generally, capacitor we know is that which stores energy. It stores charge. Okay, now but even in the induction coil it does the same function, but it stores charge for one purpose, and that purpose is that whenever like we were told here, the capacitor is used in the primary induction coil. It is because when the circuit is broken, it is there to store the charge when the circuit is broken. So if there's a disconnection in the circuit, instead of the voltage to flow freely, it will be stored in the capacitor. Okay, a high induced voltage is used to charge the capacitor, so it stores or it charges the capacitor. Now if it does not charge, will flow out and cause a spark. So instead of causing a spark, that excess voltage should go into the capacitor, so the capacitor store it. Okay, so when there's a break in the circuit, the capacitor helps to store the charge so that there will be no spark. There will be no release of spark, so that there will be no release or spark from the system, and that is the work of the capacitor. It helps to prevent electric spark, and that is the answer for number 37. Number 38 says a cell of EMF 1.5 volt is connected in series with a 1 ohm resistor, and a current of 0.4 ampere flows through the resistor. Find the internal resistance of the cell. Now when you hear the word internal resistance and you are seeing current and you are seeing every other thing like this, now you are seeing EMF 1.5 volts, you are seeing internal resistance, and you are seeing another resistance. Whenever resistance, a physics question has two different resistance with voltage and current, then you need to know that that question uses this formula, the formula for EMF, and this is the EMF formula. E equals I bracket R plus R, where E is my EMF, that's electromotive force. The I is the current, and the capital R is the external resistance, while the little r is the internal resistance. But the question is find the internal resistance. That means I'm going to make this r the subject of formula, or I will solve for the small r. So that will become the I will go under the E. That's the first step. It will become R plus R equals E over I, right? Then the little r will stand here. The capital R will jump over to this side. It now becomes small letter r equals capital E over I minus R. Okay, now the EMF is going to become, from the question, EMF is 1.5 volt. That become 1.5 volt over the current is the current is 0.3 ampere, and that becomes 0.3. Then the capital R, that's the external resistance, is 1 ohm, and that is 1 here. Now and then to solve for that, 1.5 divided by 0.3 is 5 minus 1, and that's 4 ohm, and that is the answer for my internal resistance. Don't forget, any question that asks two resistances, okay, and current with EMF is an EMF question. I always call it EMF, although it is under electricity, but it is under electric circuit, but I always call it EMF formula. Now I call this formula EMF formula. That's E equals I bracket capital R plus small r, and that is what I call the EMF formula, and that is what to do. Now any question on EMF, ask them, having EMF mostly lean on this formula, E equals I bracket R plus R, and therefore my little r, or my internal resistance, is 4 ampere, and that is the answer for number 38. Number 39 says, which of the following obeys Ohm's law? Now you know Ohm's law is used in electricity. It shows conduction. In fact, what is the Ohm's law? The Ohm's law is very simple. It says that the amount of current flowing through a conductor is directly proportional to its voltage if every other factor is kept constant. Now that is the Ohm's law. It is just between current I and voltage V. Current I and voltage V. We don't mention resistance. Resistance is only a proportionality in the Ohm's law, but the Ohm's law says that the amount of current flowing through a conductor, okay, is directly proportional to the voltage of the system, and that's just the Ohm's law in simple way, because you must mention current and you must mention voltage and you must mention that they are directly proportional if every other factor is kept constant, and that is the Ohm's law. Now, but which of these things does not obey Ohm's law? You know, Ohm's law shows how electricity flow through conductors, right? Now all of them are conductors. Now which of them obeys Ohm's law, please? Now not all of them are conductors, except one. One is a pure conductor, and that is the one that obeys Ohm's law, because Ohm's law shows conduction. Okay, now electrolyte. Not all electrolytes are obey Ohm's law, because not all electrolytes are conductors. Okay, so electrolytes obey, but not all of them. Okay, because we have weak electrolytes and we have strong electrolytes. So not all of them are the same. Not all of them obey Ohm's law. Then what about metals? All metals obey Ohm's law. Then we have diode. Diode does not. Diode does not obey Ohm's law at all. So diode is one of those things that do not obey Ohm's law. Then glass is an insulator, for God's sake. Glass does not obey Ohm's law at all. So the only one that totally obey Ohm's law, obey Ohm's law, are metals. All metals obey Ohm's law, and that is it. Don't mind me, I just created a diagram here. Look at voltage. It is working. Voltage is work done in a circuit. Is the amount of work done between 2 points. That's moving from this point to this point. The amount of work done between 2 points is voltage, and I think that's why it is drawn this way. Then current is the one flowing, okay, and then resistance is the amount of opposition to flow. So resistance is saying, oh my, is heavy. Then current is saying, currently I'm not traveling very fast. Then voltage is there pushing, right? So that which flows is current, but voltage is the work done between 2 points, and resistance is the opposition, okay, to the flow of current, and that is the answer. So the answer is just metals obey Ohm's law. Number 40, electric costing. A house has 1040 watts and 500 watt bulb. How much will it cost the owner of the house to keep them lit for 10 hours if the cost of a unit is 5 naira? Now we have all these things said now. Now this is electric costing, and I will give you a master formula to find how much electricity is at any time, any day in physics. And the master formula is just this: electric costing is power in kilowatts times time in seconds, and the unit cost. These three things are what we use to find electric costing: power in kilowatts, time in seconds, and unit cost in naira. That when you multiply the three of them, you will get your answer for electric costing. Now let's talk about power first. What is the power? The time is 10 hours, right? The time must be not in seconds, please. The time must be in hour, because electricity is charged per hour, not per seconds. Please take note. Every other thing in physics converts time to seconds, but in this topic you must not convert the time to seconds, because NEPA or PSCN don't charge us per second. They charge us per hour. Okay, so time must be in hour, so it is 10 hours here for the time. Then power is what? What's the power? You know, they said 1040 watts, so you have to multiply 10 by 40. That will become 10 times 40, and that's 400. Then you have to multiply, they said 500 watts. 5 times 100, that's 500. If you plus 2 together, you're getting 900 watts as your power, but you must put it in kilowatts. That will become, if you divide it by 1000, because kilo is 1000, so 900 watts divided by 1000 is 0.9 kilowatts, and that is the power. Okay, 0.9 kilowatts is the power. Then the unit cost, they said that the company is charged a unit of 5 naira. So the unit cost is 5 naira. Just multiply the time, the power, and the unit cost, and you get your answer. So the power is what? 0.9. Time is what? 10 hours. The unit cost is 5, and that will give me 45 naira as my electric costing. And this is the way to solve any question in physics on electric costing. It is this simple, it is this easy. It's not something that anyone should fail. And that is the answer for number 40, and that brings us to the end of this series. Don't forget that if you learn something and you want to get more content from us that will better help you understand physics, click on the like button, and we'll get to reach you with more that will clarify a lot to you. Until we see you again, guys, take care of yourself, and bye for now.